Today on Teardown, I'll be tearing down an Epson Power Light 1220 model H368A. This is a three-way LCD projector and for the most part still works. However, the polarizing film on the inside of the projector has started to degrade, resulting in darkening on the left and right side of the image. So, we're going to get into this like a kid on Christmas because there's some good optics on the inside, which include that acrylic glass and that X cube. So I'm going to remove all screws that I see on the outside of the projector and pop the top off. Alright, that looks like all of them needed to be removed to take the top case off. So go ahead and see what's on the inside. Maybe we can even run this projector open, and that's always fun. Oh, we're still getting caught up. Oh, there's one more screw in that area. Always one more screw. Alright, here we go. And we're in. And of course there's a ribbon cable going up to the top button, so. And another cable for, looks to be a sensor to tell the projector whether the door on the top of the lens is open or not. That's something that's easily bypassed. Remove that. Remove that for the time being. There we go. Huh. Well, it looks like we're not going to be able to run this open easily, because even if we did, the board would obstruct what we want to see. So no point in trying to do that. So continue we shall. Probably should undo these all first. So let's remove the main board. And the main board here in this area is basically the motherboard of the projector. It handles the different signals and the digital bits. It does signal conversion and processing, and it runs the LCD panels on the inside of the optical train. We'll see those in a bit. Alright. Come on up. Yeah, there's not much to it. It's a projector board. We got all of our inputs here. More digital bits here. You can go ahead and take a look at that. That is nice. I'm an optical person, so I don't care about that. This is what I care about here. Well, let's see what we have. Alright. So, looks like the lamp comes in this way. There's probably going to be, in this section, a kaleidoscopic beam homogenizer. Well, we'll see if that's what we find in that section. Looks like I already loosened those up. And there's the lamp. So it's a high intensity discharge lamp. Nice little lens on the top. I'll be taking that. Okay, what's next? This section. That got dangerous. Alright, what do we have here? This is the entire optical train. On this side, we don't have a kaleidoscopic beam homogenizer. We have one of the multi-lens ones. So here are two lenses on the inside, and they have pieces of glass that have a lot of little lenses. They're called a multi-lens or a micro-lens array. Lenslet array is what they're called. So there'll be two lenslet arrays. Put that off to the side. That make the beam homogenizer. Zoom in. Well, let's take a look at the entire optical train now. So, the lamp comes in here. Oh, that's that. The lamp light comes in this way. And there's two lenslet arrays. So there's one. And there's another one. And then on the inside, there's a third optic that nobody talks about. And that is a dual axis polarizing plate, or sorts. I have no idea what you call them because nobody talks about them. But I'll explain to you what that is later on in the video. And I'm going to be the person who talks about them. Anyway, so, I just want to pull optics out. Anyway, the light comes in this way. We have a couple of dichroic pieces of glass and a couple of lenses. So here's one dichroic piece of glass. Let's observe what it looks to do. I'm going to pull this one out. It looks to pass red and green and reflect blue. So that's what that does. So blue light gets reflected this way. The red and green pass this way. We have another lens here. We have this optic right here. This looks to pass red and reflect green. So green goes up this way. And then the green goes up this way. The red comes through here, gets bounces off here, goes in this way. So white light reflects off your blue, comes in here, reflects off blue, goes in this way. So this is your blue LCD. The green and the red portions of light coming through here. Green gets reflected up through this LCD here. And then the red continues to pass on through, reflects up, and then goes in through this LCD panel here. So red, green, and blue. And that output gets focused with this lens assembly here and out as a projected image. So very simple optical train when it comes to color. But remember, this is an LCD projector, so like all LCDs, it works on polarization as well. So let's get some of the other optics out real quick. Looks like these are just spatial filters to block out some unwanted light. And optics retainers. Why aren't you coming out? Don't make me get angry. I'll get angry. Alright, let's start pulling out optics. Here's that polarizer optic I was talking about, that dual axis polarizer. I'll flip it around. If I have it this way, you see that there's some metallized bars on the surface here. But if I flip it around, boom, they're gone. Now it appears like you can see through the whole optic. Flip it around, bars. No bars. What's going on? Well, to show you that, I'm going to pull out one of the other optics here, which is a polarizer. See if I can get to it. Oh, they got that glued in very well, don't they? Come here, you. Are you the polarizer? Oh yeah. Okay, so this is one of the polarizers. if I rotate this now, you'll see that the sound changes in that optic. Let me get a real polarizer. Hold on. Alright, let's try that again with the real polarizer. So, I'll put this over, and I'm going to turn it, and you'll see that it changes. Now, what this plate does is that light comes in this way. That's easy to understand, and the light that isn't used gets reflected back into the lamp housing, so it can be recycled and reflected back out. We're going to take a look at this section here, and you'll notice that the glass is joined in 45-degree angles. You'll see that they're angled. That's close enough to 45 degrees. But anyway, so what happens is when the light comes in this way and it gets reflected, that reflected light is then polarized just like it would be off the surface of like the road or water. And that's going to go with the plane. So the light that passes, reflects, and passes is polarized like this with the normal. And then the light that goes straight through and doesn't get reflected ends up going through these pieces of polarizing film on the top. So you'll see there's a strip of polarizing film, there's a strip of polarizing film, and so on for every other glass segment. And those are the ones that go all the way through. I think, yes. Anyway, the ones that go all the way through go through that polarizer instead of getting reflected, and those get polarized in the other way. So those get polarized like this, and then the ones that are reflected off get polarized like this. So we have two axes of polarized light that comes out of this piece. Now, these are polarizing film, and they're kind of geared towards a specific band. So in a video projector, you'll see that some of them will do like red, for example. Let's see, this one is the blue, so I don't think we're going to get any color out of that at all. Oh no, yeah. Let's see, I'll flip it around the other way. So some of these you'll actually get different colors out of instead of just the grayscale. So really interesting. No, that was the blue. Let's pull out the red, and oh, the red doesn't have one. Interesting. Oh, that was a great idea until it wasn't. Let's see what the green does. The green doesn't have one either. Craziness. I know I only pulled out one. It's an incomplete projector, I tell you. Incomplete projector. Well, that's okay. I plan on taking apart a few projectors this week, so you'll see it eventually. Let's continue to pull out optics. These ones are stuck in. Remove this, actually. So this is a dichroic piece of glass, and it's a thin film optic. It has a coating on there which will reflect a certain wavelength of light, or general group of light, such as the blue on this one, and the rest of the light passes. And it works just like how soap bubbles and oil slicks work. Really cool optic, very handy to have. Lenses, also very handy to have. Here we have a biconvex lens. A positive meniscus for all you optics folks. Another biconvex lens. Piece of dichroic glass. Always useful. More little lenses. Okay. We're going to have to get a little violent to get the rest of the optics out. Except for that mirror. First surface mirror. Okay. Oh, I'm going to flex the edge, see if I can loosen it up. Or send plastic bits flying. One of those. That is really in there. That is really fragile plastic. Alright, there's one of the lenslet arrays. Here's the other. Give me your lenslet array. Alright, so let's take a look at these, which are the beam homogenizer lenslet arrays. So what these do is these will refocus and redistribute the light from the lamp, so you get an even intensity plane from the lamp. And what this does is it makes all of the light that you see coming out of the projector homogeneous. So that means that the light that's way out on the edges is the same intensity as the light that's really in the center. Now, unlike a flashlight, you don't have that bright spot, and it gets dimmer as it goes out. And that's what these do. These also do another thing. You'll notice that one of these is coated with a reddish kind of reflection. And that coating is to block out the infrared and the ultraviolet from the high intensity discharge lamp. It's quite a bit of nasty light coming off of that. So they try to do their best to keep that out of the eyes and out of the optics, because it's really hard on them. Otherwise, they just have a general broadband coating, anti-reflective coating. Very nice optics. And on this side, well, I wish all projectors just crumbled like that. That'd make things so much easier for me, wouldn't it? Got one more mirror over here. That's ridiculous. So what heat does to the plastics, it makes them brittle. That is unreal. I've never had a projector that just broke apart like that. That is unreal. Ooh. I got it. Alright, where was I? Oh yeah, one last lens. Another biconvex. Positive meniscus lens. Quite a curve on that. That is strangely therapeutic. Oh, and I can do that. Nope. That was a little much for me. That's nuts. It crumbles. It just crumbles. Alright, let's get inside of the three-way LCD assembly. Now we can. Alright, so it looks like this is held on by just a little bit of glue. Oh, we'll be able to break this off, hopefully, pretty easily. I want to kind of keep this whole thing together. It is nice and small. Let's see if we have our luck with that. Oh, that's tough. When in doubt, heat gun. that's why I really have no place to grab. Oh, that's nice. Okay, let's take a look at this section here. So, we have our cross cube right there in the middle, and that's what joins the three colored images together. So, if we take a look at the projector, the X cube assembly, we have three LCD panels on it. This is green, this is blue, and this is red. And then we have this cross cube on the inside. Now the cross cube is an interesting one. It only has one dichroic surface on it, and the other surface that's on the red is actually a polarizing thin film section. So I want to show you something real quick here. Let's see if I find the right angles in this. Kind of hard to do, unfortunately. Yeah. Yeah, so you can kind of see it reflects blue here, but if I flip it like this, it doesn't have a colored reflection the same way. So this angle, we have the blue dichroic section, and on this one we have the thin film polarizing section. It's hard to explain, but that's the way it is. Let's see if I can show you with the polarizing nature of this optical assembly. Oh. Oh, it's really hard to show you, isn't it? Alright, here's an X cube for demonstration purposes. Now let me show you how these things work real quick. If I tilt it this way, we get that yellowish reflection. And if I tilt it this way, we get that bluish reflection. Now on the inside, there is a dichroic surface that reflects blue, and it passes red and green, which is that surface here. On this surface, you're not seeing the red. That's actually a filtered reflection of the light that's coming through this dichroic layer in the blue axis. So the color you're seeing here is the remainder of the light that's going through this axis. So white light comes in through here, and it gets filtered on this axis. And the total internal reflection is what makes it look colored, but it's not colored. So I get it perfectly angled. See, I should be able to make the majority of the color go away. Yeah, unlike the blue, it's really vibrant. Now you can see no reflection there, reflection there, no reflection, reflection. Now, let's go ahead and view this with a piece of polarizing film. On this cube, you'll be able to see some of the polarization effects a little bit better. The important thing to note, as I said, very few people talk about this, is that these are not all the same. If you take a look, they actually do have little identifiers on them, such as this one that says R, L, R. And that's about the polarization that these screens have. So the way this is assembled and the way it works, it doesn't only just work on the color, but it works on the polarization, just like an LCD calculator screen or display would. So where's the other piece? So this is one polarizer, and then LCD panel. Then you have some other polarizers on the inside, and you have the X cube, which reflects blue using dichroics, passes green using dichroics, and then reflects red using thin film polarization. So it's tricky things to understand. But, I really like this little assembly. I think I'm going to keep it just as is. I mean, it's adorable. Looks like something you'd give a name to. Oh, let's see, what else do we have? There's the front focusing lens assembly. Probably keep that the way it is for now. See if that comes in any use. You know what? I'm going to clean all this up before we get into the electronic stuff. Alright, let's get into the remainder of the projector now, which includes this little power supply, some fans, and it looks like one crap speaker. Go ahead and rapidly undo these screws. Nice little blower assembly there. Ducted fan. Nice little half of a blower fan. Surface position. Yeah, that's weird. First time I've ever seen a blower fan without the other side in a projector. Looks like more cost-saving measures were taken. Nice tiny little lamp driver. What, 170 volts? Input? Does not say. They usually 170 volts AC input from what I see. Alright, what else? Go ahead and take the power supply out. So this board right here is the power supply for driving the electronicals and smart bits. Has a big eye-side capacitor. That's for doing most of the filtering for the lamp inverter ballast thing. So the 170 volts is going to be supplied right off that. I bet you is going to be leads racing. You really can't see. Interesting. Got all the diodes and MOSFETs on this heat sink. We're keeping them cool. And what do you put out? Yeah. Nice little power supply. Built at a cost though. Definitely built at a cost. It's so cheap they had to put all the mains filtering on a whole different board. But I'm sure they did it for a reason. They always do things for reasons. Give me all your bits. Now you have the mains input filtering board. Oh, looks like we have mains input filter, a class X capacitor, common mode suppressor, another class X capacitor, a metal oxide varistor. Are you going across through? Yeah, looks like a metal oxide varistor. Fuse, a couple more class Y capacitors. Yeah. Nice little input board. A heavy duty tactile switch. Nice for those analog heavy hardware power electronics enthusiasts. Get out of here, you razor beast. And lastly, fans. There's no projector is complete without fans. Especially the ones with lamps in them. They get hot. There's that terrible speaker we were talking about. Die, you stupid piece of absolute terrible garbage. I'll save the magnet. Alright, got some screws. I'll save those as well. No, don't need that. Don't need that. Alright, let's clean up the desk and go through everything that was in the projector real quick. Let's quickly go over the stuff that I pulled out of the projector and wrap up the video. I'll have 3 first surface mirrors, 2 dichroic pieces of glass, which are very handy to have, especially when working with lasers. And got 5 lenses. One of them is plano convex. The other 4 are biconvex, positive meniscus lenses. One of them has one of the polarizing filters on it. And, the other polarizing filter I was looking for was on the top plastic cover that went on the optical train. Now, all 3 of those polarizers are present. I turn this, you can see that they change color a little bit. That's because I work underneath a polarized light. I have the dual axis polarizer plate right here. That's what I'm calling it because I have no idea what else to call these things. And both of the beam homogenizing lens arrays. Let's see what else. The dichroic X cube, PBS cube optic, and the 3 little LCD panels. I'm going to keep this together just as is because it's a cute little interesting assembly that'll fit on a desk nice and easily. And I have the main focusing output lens assembly, which I'm also going to keep as is, simply because having a compound lens like this with the adjustments can be very handy to have on an optical table. I got the lamp here, and that is a high intensity discharge lamp. Looks like it on the front. It has a bi-concave lens, a negative meniscus lens. Pretty tiny lamp. Take a look at the electronics. So, little lamp ballast. So that drives the lamp. Takes 170 volts and puts out lamp voltage necessary power. Got the main power supply here. So this takes the mains voltage off the filter board and puts out voltages for the logic board, such as 5 volts, 12 volts, 24 volts, and so on and so forth. And it also takes and provides 170 volts DC to the inverter board, if I'm correct on that. Nice little heat sink on the bottom, MOSFETs and diodes, and the high side, low side switching. Nice little assembly. Got the top panel board. It has a couple of switches on the top, pretty nice switches, and a couple of bicolor LEDs. I don't know if they're green and orange or green and red. I'm not going to find out right now. I'll do that on my own time. Off you heathen. Got the main logic board. It looks like there's an FPGA here, some RAM. This might be ROM, not sure. Analog devices, probably an analog to digital encoder for handling things like the VGA, that component in S-video inputs, as well as the analog portion of the HDMI. RAM. Not sure what this does. Okay, like here. Oh yeah, so power comes in here. We got all this section in here, so inductors and some of these little chips could be voltage regulators or MOSFETs. Most definitely is MOSFETs here and here. That's for doing power rail management. So it takes like the 5 volts and switches it down to, for example, like 2 volts for the processors and stuff like that, because they run at a pretty low voltage. These could be LCD drivers right here, since they're close to the LCD ZIF connectors. But yeah, it's the digital bits. That's what I'm least interested in. I'm an analog guy here. We got the filter board, fuse, 2 class Y capacitors, metal oxide resistor, class X capacitor, common mode, choke, another class X capacitor, a filter, and here's where the mains comes in. No, the mains comes in here. So this actually goes out to, yeah, that goes out to the power supply board. So just a little filter board, nice little clunky switch on there, and that went to the lamp cover. That way, couldn't try to turn on the projector with the lamp door open. I'd be ashamed if something bad would happen. Let's see, fans. So I got a couple of fans. This one's interesting. This one kind of needs to be contained in this whole assembly because the fan itself doesn't have any kind of cage around the blades. So kind of needs to stay together in one ducted fan unit. Not quite useful. I got a couple of other blower fans here. These are nice and caged. This one isn't. This one was just mounted on the side, so finding use for that's going to be interesting, but I'm sure I'll find a use for it eventually amongst the other 50 billion projector fans I have. Well, I think that's it. I hope you enjoyed, and as always, stay tuned for more.